Hello, my name is Mark. Welcome to my shop. As many of you know, I am a scuba diver. I dive a lot here in Deer Lake. One of the things that I need, however, is I need to have an underwater camera system so I can survey to find good dive spots, sunken boats, sunken treasure, interesting geological formations. Many of you have been watching my videos over the years, and the camera system that I've been building on and building on and building on. This camera unit, this is version 2. This is last year's camera unit. Basically, you tow it behind the boat. It has two 10,000 lumen flashlights that I waterproofed and a good color camera. So you basically just tow this thing down through the water. You've seen my videos. Worked out really well. A couple of things that I wanted to improve. Number one, even though these are 10,000 lumen flashlights and very bright, I need more light. I always need more light. And that camera's a good camera, but yeah, I'd like to have better video, less grainy, more, not so much motion blur, that kind of thing. So over the winter here, I've been working on a new unit. Let's take a look. This is the new unit. This is the case that I built for it today. 3-inch Schedule 80 PVC pipe, solvent welded. The idea here is just like this unit, flashlight, camera, my flashlight, camera, flashlight, just like you're going to see it. This one's way different though. If we look at the original one, you see how that the flashlights stick out in front of the camera so that the camera could actually see the glare of the flashlights in its field of view. In this unit, you can see that I've actually recessed the flashlights behind the camera, so that won't be a problem. It won't be so glary. How this works, I've got a piece of half-inch plexiglass, bulletproof plexiglass trapped here. I've cut O-ring mount here so that all the electronics, my computer, my servo system, my radio control system, all of it's going in here. Batteries are going in here. LEDs are going in here. More batteries and LEDs here. These guys screw on. And the plexiglass seals onto that O-ring. Watertight seal, should be good for several hundred feet deep. Way cool. Couple things that are going to make this thing different. This guy just towed behind the boat. I would tow this behind the boat. This unit, on the other hand, is going to be completely opposite of that. These are 12-pound thrusters. They operate on 12 volts DC. They're pretty high current. Going to be huge batteries inside the unit. But I'm going to mount one thruster there, like that. Another thruster there, like that. And a couple more to give me vertical. So I'll be able to take these signals, run it into my processor here, run it up the video line, and this guy will tow the boat. In the boat, I will have a joystick that will give me full control of this thing, like you fly a helicopter. It will drive through the water. The cable will trail it, and this guy with these thrusters should be able to pull the boat. Instead of me pulling the camera will pull the boat. That'll give me a lot more control over where I go, and when I see something, as you saw in my videos before, if I'm going along and I see something I like, it's really hard to swing the boat around and come back to it. It's difficult. This guy will have full three-dimensional control over where he goes. Should give me great video. The thrusters, any of you that are been working in the hobby of radio controlled cars and stuff, you recognize this. This is what's called an ESC, electronic speed control. I have several of these that will run the thrusters. These guys are current limiting power supplies that will take the 12 volts from the batteries inside these containers and boost it to a point where it will run my LEDs. Now, previously, I'll give an idea of what kind of light we're going to have. This is the LED that's in the front of the camera. It's about the size of a pencil eraser. And it, like I say, it produces 1,000, 2,000 lumens, something like that. Let me show you the LEDs that I'm intending to put on my new system. That, I'll give you a size comparison. That yellow disc replaces that yellow disc there. This guy is 20,000 lumens. And I'm going to have one here, one there. So about 40,000 lumens. The science that I've looked up and done some research on, to give you some comparison, 20,000 lumens, if we put two of these together, I'm going to get 40,000 lumens at noon, at the equator. If you look at the sky, at the sun, at noon, at the equator, your eyes see about 50,000 lumens. So I'm 40,000 lumens. This guy should be about as bright as the sun underwater. Seriously bright. Now these guys, these LEDs are going to be mounted outside the container on the water side because they need to be water cooled. These run seriously hot. And if I put them directly in contact with the water, the lake should keep them cool enough to where they don't burn up. So I have the electronics, and it's going to have a computer in here. The computer I'm running is called an Uno. If you've ever heard of that, some of you have, I'm sure, but I've written a program that runs all the servos, runs the video control, runs the telemetry that comes up. Should be way cool. This is just the case. I'm now going to start mounting the gear in the case, and we should have first videos out, I'm expecting middle of summer. So thanks for watching. Thank you for coming to my shop. Those of you that like my videos, please comment and share. I'll see you on the water. Bye-bye.